JUIT is the first private university in Himachal Pradesh. It has a 25-year vintage. There's a tremendous amount of innovation that's happening in the university, whether it's on the incubation side. The university has an incubator which is called RIDE. The university is also focusing highly on increasing its international presence. Apart from this, we are investing heavily into infrastructure. So you would have seen like the beautiful DLC classroom. These are state-of-the-art classrooms. These are classrooms on par with the best universities in the world, whether it's the Harvard or Stanford. We are now having that kind of infrastructure here.
I'm proud of saying this particular fact that the average package of this university is increasing, and as on this day, this is 7.23 lakhs per annum.
Here in the JP University, we have a complex which is one of the best. We figure in the first 10 most beautiful campuses in India. That in itself actually says a lot with respect to the infrastructure which we have created for our students, for their academic excellence, as well as their overall development of the best. We have about 14 hostels here. The amenities which we provide them are par excellence, the world-class facilities which we provide them logistically, administratively, and our academic block. The vibe in itself is very, very positive.
The highest CTC in last 5 to 6 years is 50 LPA from Amazon and Adobe.
I am delighted to welcome you to a place where knowledge meets purpose. At our institution, academic excellence is just the beginning. We foster innovation, encourage interdisciplinary learning, and nurture a culture of critical thinking and creativity.
JUIT, as you all know, is one of the most sought campus in India. Those students who have visited us and the faculty who is working here is par excellence. And this is a campus which is having a focus on research, innovations, and also on international collaborations.
I am here in JUIT since inception of this university. Besides outstanding infrastructure of the university, everyone at JUIT has contributed immensely to its tremendous growth. We are lucky to have driven educators who make it sure that our students have a holistic development.
We have one very other interesting development in the form of Ramanujan Universe. That is a supercomputing facility wherein the students can actually explore their complex projects and can do better ideas in the form of large language models or solving any other complex problem.
Nowadays, we have more work on IoT. The students are also working on the agriculture projects, different projects.
Hi, I am Preetmay Patel. Besides me is an autonomous agricultural drone prototype.
Good morning everyone. My name is Gupta and here is my friend Sambhav Thakur. This is our minor project. We have modeled it after Israel's pinnacle of air defense system.
Yes, I definitely feel it is easier to make friends on campus. First of all, you connect with your roommate first, and we have many clubs and committees in our college which help us to connect with our seniors as well as our batchmates.
We at JUIT actually delve into genres that are beyond the scope of academics, such as sports, literary, technical, and cultural.
A very good morning to one and all. So we like to begin this program by welcoming our guests for today, Mr. Jagjit Singh Manjaji. He is the chairman of IGBC Chandigarh chapter. I'd also like to welcome our expert speaker for today, Dr. Prateek Srivastava. He is an IGBC AP and he'll be delivering today's session on sustainable material and efficient technologies for green buildings. I will also like to welcome our HOD, Professor Ashish Kumar, for his valuable presence, and all of my colleagues, students, and participants from all around the world. We have received a number of participation for this webinar, and it is very welcoming to see that students and especially young generation is very much coming towards sustainability. They are understanding the concept and they are trying to implement it in their own roles at different positions, whether they are currently studying here or are our faculty or our alumni who have passed and now contributing significantly to GDP of this nation. So I like to welcome all of you to this short program of 1 hour. And to open this program, I'd like to invite Mr. Jagjit Singh ji for his opening address. He is currently also the CMD of PCL Housing, besides being chairman of IGBC Chandigarh chapter. And he is an entrepreneur. He is developing a mega integrated township in New Chandigarh by the name of PCL Gateway. He is the president of CREDAI Punjab, a leader of real estate sector. He is actively also involved in NGO Guardians of Nature, which is working for preserving planet Earth and has planted more than 10 lakh trees. So with these words, I like for your opening remarks, sir. Sir, over to you.
Thank you, Tanmay, for introducing me. In fact, it's always pleasure to interact with the youth which is going to carry forward the flag of the nation, the flag of the environment, the flag of life, because environment is life. This initiative taken by JP University is a great initiative, and IGBC always supports such initiative. We are partners in this program also. The best thing which I saw when the JP University is introduced, the green coverage and the infrastructure, because it's the infrastructure and the green coverage which motivates everyone to work for the making of the great country, India. And I think all those who are studying there they are privileged, and we push that most of the talent of the country should be given this kind of environment for better understanding of environment, for better productivity, and for better contribution to the nation. This initiative, in fact, it is because it is involving youth and making student awareness, increasing student awareness about the sustainability, which is a young force of professionals, and introduce to them the challenges which the universe is facing currently. Recently, we have passed through Corona. It has taught us a lot of lessons, but I think human beings always err in achieving the end targets. The challenges which are being faced by the universe today, the climate changes. Himachal is one of these sufferers when we see the excessive rains and the cloud bursting, which in fact destroys a lot of creations of human being, and human being should learn from it. Then there
And also, if I will not take so much time, because this is the topic, sustainability is having a very large aspect, and we are all very cautious about that, or civil engineers particularly. So we see that sustainability is the word which is dealing all where, and all of you know that this AI summit is basically going to happen in month of the February, this month, 16 to 18 in the 16 to 20 in the, yes, in Delhi, AI summit. And in this AI summit, the word sustainability is also there, and with their three primary sutra, that is the people, that is the grow, and that is the planet. These three sutras are also there in this. So people, then planet, and then the growth. So in this aspect, if we talk about this construction, that also truly valid. People, we have to do work for the welfare of the people. We have to same time save our planet in a sustainable manner. And third is the grow. We have to grow. So that all three aspects we have to take simultaneously. And I think with this kind of interaction, with this kind of green talks, and with experts and discussions, will definitely improve the sustainability of our environment. So with these words, I thanks to once again all of our members who have joined here, and I am hopeful and definitely see that we will having some positive impact on our environment, on our system with this kind of talk. So over to you, Tanmay.
Thank you. Thank you so much, sir, for your insightful words and giving us the go ahead for this program. So now I'd like to invite our main speaker for today, Dr. Prateek Srivastava. He is an IGBC AP. He has completed his BTech in mechanical engineering and MTech in thermal engineering and a PhD in HVAC system. He was visiting researcher at Lawrence Berkeley National Laboratory, US, and Bhavan intern at Oak Ridge National Laboratory, USA. He has published more than 20 research publications in peer-reviewed journals and published one book. He has 10 patents on his name. Presently, he is working as a managing director, Sustain Energy Tech Private Limited. His company works in domain of green building consultancy, energy audit, and HVAC designing and installation. Sustain Energy Tech has designed and installed various projects of radiant heating and cooling systems in Pan India. Sustain Energy Tech has completed various green buildings certifications projects, factory, residentials, and commercial buildings also. He is also an active member of Radiant Cooling System Technical Group, IGBC AP certified water consultant. He has served as secretary in ASHRAE Chandigarh chapter and program chair of ASHRAE Chandigarh chapter. So we like to heartily invite Prateek sir again. He has already given one talk with us on radiant cooling previously, and now he is back again for today's very important topic on sustainable materials and their applications. So I like to give you the stage, sir.
Thank you, Tanmay. Am I audible?
Yes, you are.
Yes.
Okay. So first of all, I would like to thank Majha ji for the welcome address. I would also like to thank Professor Ashish Kumar for organizing this event. And I would like to thank Nilesh and Tanmay for curating this event at such a short notice. And I think while we were discussing for this event, so we were just thinking to come up with some materials and technologies. So that's how we planned for this today's session. So I think, so I'll just share my screen. So is my screen visible?
Yes, it is visible. You can make it full screen, sir. Yes, now
Okay.
it is.
Okay. So the basic background is to discuss the materials and technologies. So I was just while just building this slide, I was thinking about my experiences while doing the green building certification projects. So as you can see, the building in the right side, so it looks green, but rather just putting green plants and green vegetation, we have to do lot of research, and while doing the material selection, the technologies which we are going to inculcate in the building. So and now what I'm seeing in nowadays, the scenario is much different. So because of the green building movement and the initiatives, lot of green products are coming in the market, and many a times when we discuss the buildings and projects with the clients and architects, it happens a lot that a new material has come in the market and then we have to do research over it. So many a times it happens the technology is really good, and few of the times we have seen that uh, sometimes the material also don't fit with the buildings. So recently, just yesterday, I visited a building. It was a green building, platinum certified green building. So they have used Vedic plaster on the surface. So what happened is there is a company who has come up with a Vedic plaster which comprise of cow dung, clay, and it's like it's a combination of two or three material. So they just did a sample for one wall, and later they identified they're facing some issues, and then they just changed the composition of the same materials, and then later on they identified now the plaster is coming properly and it is with his withstanding its properties. So likewise, when we go for green technologies, so we have to do some fine tuning, we have to do some kind of changes to adapt the climate, to adapt the local scenarios. So, as you all know, India has announced its net zero emission. We are going to we have our targets to achieve net zero as a country, and this is at COP26. So now, to achieve this, we need lot of professionals in the industry to take this mission to the next level. At the same time, we also need lot of money funding to get incentives, to get benefits, and also lot of green products so that our buildings can achieve this target at 2070. So let's discuss the life cycle of a building. So it usually happens that we when we plan a building, it usually take around 1 to 3 years while construction. Pre-construction, it takes around maybe 2 to 6 months for planning a building. And once the building is commissioned, during the construction of the building, there are a lot of materials which are going to be used. We do excavation, we do reinforcement. So we use a lot of materials, and every material has its own carbon emissions. While production at plant, then we carry that material from plant to the site. So green building systems has a credit that it is important and mandatory to use local materials. So source the material in such a way that it should have a distance of like 300 or 400 kilometers, so that we waste minimum energy while transporting the material to the site. So once the building is ready, then we have lot of O&M cost and lot of O&M emissions also. So while operating and maintenance, you might have seen that in commercial buildings, we get energy bills of like lakhs, and also it goes to crores, the yearly bill. So when we are using so much of energy, we are using so much of water, we are using many cleaners, chemicals, and we try to we try to use the organic chemicals, the organic cleaners instead of the chemicals, so that we can again reduce the use of chemicals, the use of carbon, and that's how we try to go with it. So when you go for a green building certification, so usually the certification ends, so the duration of the certification is usually 3 years. So after 3 years, you have to go for a recertification. And the intent of going for a recertification of project is that, so whatever claims we make while getting the green building certification, whether we are fulfilling it or not, whether we are maintaining the building in the right manner or not, whether we are managing the building in the appropriate manner or not. So we get lot of data, operating data from the building, and based on that operating data, whatever energy we have consumed during the last 3 years, whatever water we have consumed, and lot of stuff, what food waste, like what kind of floor chemicals we have used. So a lot of data comes from the building, and based on the prior submitted data which we give at the time of certification, and based on the data which we acquire from the buildings in last 3 years, we do the recertification of the building. And then the certifying agency, they just check whether the building is complying the green building norms or not. Based on that compliance, they get a recertification. So it's a lot of commitment when you go for a green building, but at the same time, it gives a lot of benefits, and especially for the mother nature. So then after operation and maintenance, every building you must have seen that there is here and while there are some kind of maintenance and renovations are going on. So at renovation again, we have lot of carbon emissions, energy consumption. So overall, this is a life cycle of a building, and one has to look very judiciously, so that we can optimize our carbon emissions, our energy consumption, our water consumption, and other resources which we are using in the building. Okay, so if you go for a green building certification, usually the broader measures of green building compliance are based on following parameters. So the first one is sustainable site and planning. So in sustainable site and planning, we see how we can manage the site, how we can plan the site, and how we can reduce the wastage and natural resource while doing the site selection and planning of the site. The second point is water efficiency. So we'll dig deeper into all these points. So water efficiency is second important aspect. Third is energy efficiency. Then we go for building materials and resources. And then another important point is indoor environment quality. So environment comprise of air and water. So we have to check the environment quality also. Okay, so now we'll dig deeper for all the individual points. So first is sustainable site and planning. So if you see sustainable site and planning, the first point is construction activity pollution. So you must have seen that in all the construction sites, there are different types of pollutions. You may find air pollution, you may find water pollution, you may find sound pollution also. Nearby a construction site, there is a lot of these kind of issues which happens. So while constructing a green building, one must adhere to reduce all the construction activity, so that the pollution has to be minimalized. Then management practices. One has to provide basic amenities to the workers who are working at the site, such as one must have a first aid box, small place for like for bigger sites, one must have a medical center. Then you must have washrooms appropriately. It should not be like that 200 workers are working there and you just put one or two washrooms. So appropriate number of washrooms should be available at site. Then you must have drinking water facility and the basic amenities which are required for workers to work at site. And if there are children's available, there should be crèche facility also for the smaller children so that the workers can work. We also have to work on heat island reduction. So nowadays, there are two ways we can see at heat islands. So you must have seen lot of air conditioners are being used, and so what we do is we just take out all the so while cooling in summers, we take out the heat from the building and we dump it in the nearby vicinity. So what we are doing is we are cooling the building and we are just warming up the surroundings. And at the same time, when you see the roof in the summers, when you have an outdoor temperature of maybe 45 or 47 degrees Celsius, your roof temperatures goes up to 65 or 68 degrees Celsius. So when the roof is at such higher temperature, so you get lot of heat island impacts. So the next one is light pollution reduction. So these are some of the main points, and there are few more. So we'll address later. So if you see in the right hand side in this picture, so first one is this is so one must have first aid facility at the site. The second one is this is a trench. So what happens is in seasons and rainy seasons, one must have trench in such a place at the site so that your soil must not be washed off, or it should not be go away from your site, or like from your project site. So in the third photo, you can see this is a car parking, and above you can see this true white nature color, which it has so we have a canopy over it. So what happens is white color has maximum reflectivity index. So it reflects most of the solar radiations and keeps cooler temperature at below. So if you just paint it with a darker color, so the temperature below will be much higher compared to this color. The next one is nowadays, if you see everywhere, we just don't find the soil, and you just feel everywhere is concrete. So this is a good way of keeping both, so that we can have a greener area also, and we can also have a pavers, so that we can maintain both simultaneously. Okay. Now, the second point is water efficiency. So when we talk of water, so I would say like in northern India, one of the worst hit areas are Rajasthan and Punjab. If I talk about Rajasthan, the water table is very down. You may find water at 300 meters and maybe 500 meters down the soil. And then when we talk about Punjab, there are a lot of places in Punjab where the groundwater is not fit for drinking, and it is carcinogenic because lot of fertilizers we are using. So water efficiency is need of the hour. The way we are utilizing water, I think we have recently seen Chennai where there was a lot of problem for the water, and it's not far away that we might face in some of the cities of India the day zero. So if we have to stay sustainable, we have to think about water efficiency. Otherwise, without water, we can't do anything. So The use of water reduction should be reduced by using low flow water fixtures, by using low flow urinals, waterless urinals, and there are a lot of technologies available to reduce water consumption in your wherever you are using the water. You can use drip irrigation system instead of normal irrigation in green areas. So there are a lot of technologies. One must uh, meter the flow. So there is a saying, whatever you can measure, that if you measure, then only you can save. So measuring is very important if you want to save anything. So you must understand that how much water you are consuming and in which areas how much water is going, so that you can make plans that how you can identify the areas where you are consuming more and how you can plan for the reduction of the water consumption. So now the second point is rainwater harvesting. So nature has given us rainwater, and one of the most purest form. So it is important to conserve as much as rainwater as we can. And now a lot of green buildings, they are being designed in such a way so that they can acquire maximum runoff for the rainwater harvesting. The next point is landscape design. Try to design landscape in such a way that native species should be more inculcated in the project. We should have less amount of turf areas, because turf areas consume lot of water, and we have to design the landscape in such a way that the runoff should be properly harvested in whatever manner we are designing. And the last point is recycle and reuse. So if I talk about a building, there are 3 points. First is reduce the consumption as much as you can by using best kind of fixtures, by optimizing your needs, by optimizing in various capacities. The second thing is uh, harvest rainwater as much as you can as per your site design and as per your availability. And the third point is whatever water we are using, we should recycle it and we should try to reuse it the whatever manner we can. So recently, there was a consultant and I was just having a discussion with him. So if I talk about Mohali as a city, it's a great city. But if you talk about the MC office, we don't have any kind of facility so that we can just, if you're generating waste, the building has to plan its own way so that how they can take the waste and they can dump it. So the government has mandated that you should segregate the waste in best possible manner and then try to recycle it, whatever you wet waste you can recycle, and then uh, the rest of the waste you should send to the recyclers. And if we talk about the water, so there are big societies in Mohali. So some of the societies are facing problem that they are, so as per the mandates they have generated the wastewater, right? Now the wastewater is getting recycled through STPs. Now the next problem is what to do with that wastewater. They are using it in the green areas. They are just putting all the all that water in that green areas. Apart from that, they are just giving this rainwater, the recycled water to the nearby buildings who are constructing their buildings. But again, they are having lot of recycled water and they don't have any plans for reusing it. So this is a problem statement and we need a solution for it. how to reuse the recycled water in best possible manner, because still we are not able to get that kind of quality of recycled water that we can, mostly we are not able to put that water into flashing. We are putting uh, plumbing lines for the flushing area, but still we are not able to get, in most of the projects we are not able to get that kind of recycled water from the STPs. So this is a problem and we have to find a solution for this problem. And because of this, now the MCs are penalizing the buildings to identify, and means the penalizing has not started yet, but the new buildings are facing some consequences while getting the approvals. Okay, so the next point is energy efficiency. So if we talk about energy efficiency, building consume around 30 to 40% of the energy of our grids, right? The entire country's generation, 30 to 40% or more than 40%, around 45% is directly being consumed by buildings. So if you want to improve the efficiency of the country, buildings are the major energy guzzlers and consumers. So we have to think about the energy efficiency for the buildings. So the first point is use eco-friendly refrigerants. So eco-friendly refrigerants is directly not a part of energy efficiency, but uh, so the energy consumption of an air conditioner is directly depends on the compression ratio of the refrigerant. So if we are able to find refrigerants which requires lesser compression ratios to get the desired output, I think that will help us in reducing the energy consumption. The second point is, so eco-friendly refrigerants, the main intent is to reduce the global warming and to reduce the greenhouse emissions. So the second point is high efficiency HVAC equipments. Now, if I talk about buildings, 40 to 45% of grid energy is being used by buildings, and from buildings, 40 to 60% of energy of a building is consumed by air conditioners. So if you want to have a efficient building, the key is HVAC systems, because they are going to consume the maximum. Low wattage lighting. So it's not about that we have to compromise with lighting. So we have to design the lighting in such a way that we have to ensure the lux level with minimum energy consumption. So we have to design lighting in this way. Now, for smaller buildings and for low budget buildings, uh, the best way is go with B star rated appliances and try to buy maximum star rated appliances, so that a very common layman who does not understand energy, who does not understand efficiency, can see that 5 star is the best, so just they can go for a 5 star machine. Now again, as we discussed in water, metering is a very important thing. So uh, for all the green buildings, we have to go. So usually metering is at a building level, which from the building level metering, we get the energy bills. But we have to dig deeper and we have to install the energy meters in such a way so that we can capture the uh, fine data of the building, that how much energy we are consuming in air conditioners, how much energy we are consuming in lightings, maybe in fans, in services. And then again, we can dig more deeper. If we have a central air conditioning plant, how much energy the chiller is consuming, how much energy the pumps are consuming, how much energy the cooling tower is consuming. So if you have a very refined data, a good engineer can look at the data and he can identify that where the losses are, and it helps a lot in minimizing the energy consumption. The next point is building system commissioning. So again, in a country like India, my experience is we design very good buildings, we install very good technologies, but many a times they don't work in sync. They don't work in balance, and building commissioning systems are basically a building block which helps uh, in fine tuning the building in terms of operations, in terms of energy water consumption, in terms of all aspects of the building. So commissioning really helps us a lot in fine tuning the entire technologies with the designed approach. Now, last but not least, renewable energy. So basically, see, the renewable energy is generation side of the energy, and the other points are towards the efficiency side of the energy. So first we have to try to generate as much as we can through renewable energy, and we have to optimize our consumption in such a way that we have minimum energy consumption in the building. Okay, so if I talk about building efficiency, envelope plays a very important role in the building. So uh, you must have seen that if you go to any ancient forts, because of better U values of the envelope, there are no air conditioners, but you still don't feel hot while just walking inside. If you have traveled to some Jaipur forts like Amir Fort, Jagar Fort, and maybe like Golconda Fort of Hyderabad, and like there are a lot of forts in India. So most of the forts, they are designed in such a way they have very good uh, thick walls with very appropriate overall heat transfer coefficient, so that we have minimum heat load which are penetrating in the building, and these buildings stay very pleasantly cool during the summers, and in winters also they don't get uh, very cold. So if I talk about the new generation buildings, we are using bricks, we are using glasses. Uh, in many of the commercial buildings, you will see the entire building is of glass. So while selection the envelope, the designer must be very judicious in terms of selection of uh, all the material of envelope. So if you see, it is always advisable to use fly ash bricks or double AC blocks instead of a red brick, because they have a better U values. At the same time, when we do the green building projects, we do energy simulation and daylighting simulation to optimize the use of the envelope. So in that, based on the data we get from the simulation, we try to do the selection of glass in such a manner that in different orientation of the building, all the four direction, we should use the best possible selection of glass, so that we have minimum energy consumption, heat penetration through the glass, and maximum lighting, maximum achievable light should come in, so that we don't use natural lights during the daytime. Then again, if we talk about the roof, the roof is usually uh, the highest temperature envelope of the building, and we have to use proper technologies. We need to use insulations, SRI paints, or there are some more technologies, so that we can have minimum heat penetration from the roof. Okay. So this is a project we have recently commissioned. I just put some data of this project. So this is a farmhouse, sorry, has come up in Himmatnagar, Gujarat. So our client was a US contractor and he wanted to have a net zero energy building. So we designed the building in such a way that this is so we are just working on the IGBC certification of this building. So this is going to be we have used insulation in the roof to reduce the heat penetration from the roof. We have used DGU glasses with argon filled glasses in this house. We have cavity walls in this project, and this is a geothermal project. So what happened is we have done 20 boards in the vicinity of the project. And in the normal air conditioning system, what happens is uh, what we do is we just cool the building and we dump the heat outside. Here, what we are doing is we are just putting the heat from the building and we are just putting it into the ground. So we have 100-meter deep 20 bores, and all the bores have, if you see these black pipes which are coming here, so this is a manifold which we have created. So all 20 bores pipes are coming from ground to this point, and then from this point, if you see these black pipes, these are going to the plant. So here we have a geothermal reversible water to water heat pump. So uh, if you see uh, this photograph, so this is a heating application. So usually if we when we do heating through a VRF system, we get a COP of around 3 or 3.5. If we do heating from a boiler, we usually get a COP of less than 1. So from this system, we are getting a COP of around 8. So for getting 72 kilowatt of heating output, we are just consuming 9.9 kilowatt of energy. So this is the cooling mode operation. So we are getting an energy efficiency ratio of 6.5. For getting 39 kilowatt of cooling, we are just consuming 6.4 kilowatt of electrical energy. So is this slide visible?
Not that much. You can zoom in maybe, or you can
Okay,
explain.
what I can do is I can open this sheet separately.
Yeah, then maybe it can be zoomed in. You can zoom in there also. We'll be able to see there.
Just a minute. So is this visible?
Yeah, no, it is much better. Now you can zoom in to particular.
Okay. So this is the ground source heat pump. Okay. So in the left hand side, if you see, these are the 20 boards from where we are exchanging the heat of the building. So what happens is the right side of this GSHP ground source heat pump is the building side, and the left hand side of this ground source heat pump is the geothermal side. So in conventional air conditioning, what happens is if we talk about the cooling mode, we extract heat from the building and we dump it in the air. And when we use water cooled chillers, again we dump it in the air itself because it's water cooled. But in evaporative cooling also, we exchange heat with the air only. So here what we are doing is we are just in cooling mode, we are extracting the heat, we are dumping it into ground. And in the heating mode, so when we heat, we get the cooling out and we dump it in the ground. So this pit, this bore, recharge itself when we go from cooling to heating, because in the winters when we heat, the ground gets cooler, and in summer when we again, like it works simultaneously in heating and cooling. So then when we come to the right hand side, so these are two tanks here. So one tank is feeding the chilled water. So here, this tank, the temperature we are maintaining is 7 to 8 degrees Celsius. This tank feeds chilled water to the air conditioning system, to the radiant cooling system, and to the fan coil units. And again, this machine has a desuperheater. So this, when we do the cooling, the heating comes here and it heats the hot water in this tank, and this gives the hot water to the building. So this is the basic fundamental of this project. Okay. Okay, so we have a small video of this plant. I just so if you see, we have two pumps here. They are just supplying chilled water to radiant and fan coil units. We have a mix-it unit here. So in this unit, what happens is chilled water comes at 8 degrees Celsius. This mix-it unit divides it into two. One 7 degree or 8 degree water goes to the fan coil unit, and another it mixes the return water temperature, and it creates a 16 to 17 degrees Celsius and send it to the radiant cooling system. Okay. So if you see, okay. If you see backside, this is a expansion vessel. So usually when we do chilled water installations, we put expansion vessels to, so what happens is when we do heating and cooling, the volume of the water changes because of thermal expansion and contraction. So to avoid that expansion in the pipes, this expansion vessel works to accommodate that. Then we have these two tanks. One is for chilled water and another one is for hot water. Then we have one more pump. And then in the right side, the red color machine is the geothermal heat pump. Okay. Now we'll go for building materials and resources. So nowadays we have like lot of companies are coming with lot of green chemicals, green not chemicals, green agents for different applications of building. At the same time, there are different types of materials available. If you talk about insulation, you have different types of material. If you talk about bricks, you have different types of bricks available. So in every material, you have lot of options available, and one has to do a very judicious selection of the material in order to get the right output from the building. So first is sustainable building material. So we have to do selection of the material which are so there are like IGBC has Green Pro certification, which certifies green building materials. So one option is you can check which of the materials are Green Pro certified, and you can do a selection from there. Or you have to analyze the material, why it is green, what is the implications of the material on the building. The second point is local materials. So the intent is one has to procure the material so that in such a way that it is being developed, generated within the vicinity of the project. It should not be like that you are building So you are constructing a building in Himachal Pradesh and you are using an imported Italian marble. So you just understand how much energy is consumed while importing those kind of marbles when you have such a beautiful slates nearby in the vicinity of Himachal Pradesh. And also you get lot of local materials for the replacement. Like at the same time, it should not be like I was doing a five-star resort project in Kerala. So that they had the intent to bring lot of materials from Thailand and from Southeast Asian countries. So because of their intent, we were not able to do that project into green building. So there are a lot of challenges, but whenever we are doing or we are constructing a building, we should have a thought process towards energy, towards water, towards the impact of the building towards the mother nature. The third point is certified green building materials. So this is a easy way to get the right material for your building. So you can check the certification of the material and you can plan accordingly. The next is building waste management. So see, there are different types of building topologies such as hospitals, commercial buildings, schools. So every building has a different kind of waste. So let us suppose if we are talking about a university, universities have lot of hostels which generate lot of food waste. If we talk about hospitals, hospitals have lot of medical waste. If we talk about factories, I recently visited a agrochemical factory in nearby Chandigarh, and what I have seen is there are so many chemicals which are like it's very high to decompose those kind of chemicals. So the point is there are different types of waste and you should have a plan or technologies to manage it or maybe to recycle it or to use it in the right way. Then the next is organic waste management. So, or the organic waste which we are getting from the buildings should be rightly composted in the building itself and should be reused in the building or maybe whatever way you want to. So, the next is construction demolition waste management. So, for this point, I would say you must have seen there are a lot of startups nowadays which create lot of meaningful products from the waste material. So we need an ecosystem which utilizes the waste in the best possible manner. Recently, I met two companies. One company is what they are doing is they are getting all the plastic waste, they are recycling it, and they are making furnitures out of that waste. I just saw one more company. Uh, so they have designed their own machine. So all the waste which is coming from the municipality, they install it in the municipality itself and they convert different kind of products from the waste. One product is they are producing biogas, they are producing fertilizers, they are trying to produce ethanol also. So again, this is a big area where we need uh, students to work on it, and we need technologies so that we can utilize our waste into best possible manner. Then again, like there is when we use wood, then it should be FSC certified. So FSC is nothing but it is Forest Stewardship Certificate. So when we have a FSC certificate, it means that when they cut one tree, they replace it with multiple new trees. So that is a legal way of using wood from the forest. Okay. So again, like lot of different kind of technologies and products we are using in the buildings, such as concrete, steel, wood, bricks, blocks, glass, cement, stone, insulation materials, solar panels, rainwater harvesting, insulated concrete forms, and so on. So I would also like to focus on few materials which recently I have come across. So one is hemp-based paint and blocks. So hemp is an excellent material. So one of the company in Delhi, they are working to use hemp in the paints. So hemp has a very good property to reduce the volatile organic compound, and also to it has a very good binding property also, and it has some more properties, so that uh, people are working to use hemp in the paint and also in the blocks to improve the values of the product. Then I met an architect in Chandigarh. So she works with lot of clay. So instead of using cement for plastering, she has developed like she works with clay buildings. So clay with proper composition of waste materials such as husk and lime. So that kind of combination they are working, and they are replacing it with conventional cement plaster. So that is an option we can think of. Then so yeah, so there are different so this also gives a lot of opportunity for all of you students to think in this direction and to come up with ideas for waste, for green materials. So lot of research is still required. Lot of interest is required to pursue your careers in this field. To have different kind of, like what I told you, is lot of waste is available. We can think of how we can use that waste into meaningful products. So all these things are available. Okay, so like the first thing is bamboo. Bamboo is a very good substitute of a wood. So bamboo is rapidly renewable. It usually grows in 3 to 5 years, and it does not require much water for the growth. So now a lot of bamboo is being used in green buildings. Recently, you might have seen the Bangalore airport. So in Bangalore airport, lot of bamboo is used for the interiors and lot of stuff, which is quite beautiful. At the same time, it is rapidly renewable. So this is a good option. Then like silicate paints, we can have vertical gardens. Then we can have natural stones instead of like engineered stones and like imported stones. Now, as I told you, there is like bio bricks, which in the bio bricks. So it is like agricrete is an option, hempcrete is an option. So there are different options available in bio bricks also. So like there are different technologies available, and we have to think of the best use of the technology in our buildings. So last but not the least, the indoor environment quality. So, so I think this winter was really harsh for all of us. especially in the northern belt of the country. So in the entire northern belt, the air quality was really poor. Delhi knows better, so we are still in a better situation, but we have to think of it. So every green building must have a fresh air ventilation. So as per ASHRAE standard 62.1, there is a calculation available to how to calculate the fresh air for the ventilation, and based on that, one must install fresh air system for the buildings. Second is thermal comfort. So if I talk about conventional air conditioning systems, so we find heat pockets and cold pockets in the building, and we are when we are not using air conditioning system again. So the aim is to design the building in such a way that it should have a thermal comfort, so that whosoever is sitting in the building, let us suppose if there is an office building, and if we are not able to maintain the right kind of thermal comfort, the productivity of the occupants will highly reduce. And that is the reason which whether you design a very good building, if you do not provide a good thermal comfort, uh, it may have severe consequences. Then we have smoking prohibition in green buildings. Uh, if I talk about VOC levels, VOC is nothing but volatile organic compounds. So we have to select the interiors of the building in such a way so that we generate as much minimum VOC as possible. So low VOC paint should be selected. While selecting the carpets, upholstery, all those things, we should select the material in such a way that it releases minimum possible VOC. Then when we put fresh air ventilation system, so it also increases the energy consumption of the building. So we try to put CO2 sensors in the building. Whenever the CO2 ppm levels are higher, the fresh air system should pump in fresh air. And when the CO2 of the normal, CO2 sensor feedback system for ventilation system is important. Interior lighting and daylight should be appropriate. It should not be like that. It's a green building. We should not switch on the light when the lux levels are low. So we have to make the best use of daylight, and we have to provide appropriate lighting throughout the year. We should have good views in the building so that the person who is working in the building should have a good experience while working in the building. And again, the last point is acoustic performance. You must have seen that if the acoustics are not proper, you get a lot of echo in the building, especially in the bigger halls and like those kind of areas. So again, acoustic performances of the building is also important. So these are some practices we follow in green building. So the site should have a barricade so that the pollution should not go outside. If we have trees inside your project, it should be well covered off so that they don't get any hamper from the construction of the building. Topsoil should be preserved. This is a problem which I have seen in many buildings, in conventional buildings. First, they excavate, they sell all the soil, and then later on, while doing the green areas, they buy the soil from outside. So topsoil is the most fertile soil, so one must preserve within the vicinity of the project so that in the later stage for green areas, that soil must be used. Sedimentation tank basins to this is important to avoid flushing of the soil while in the winter in the monsoon seasons. So this is again important. Next important thing is construction workers' health and safety. So safety signages should be there. First aid facility, hygienic drinking water facility, hygienic toilet facility, clean and hygienic labor accommodation, PPEs for construction workers, safety harnesses for scaffolding, crutch facility. These are some of the important things which should be available for uh, the people who are going to work. So one should have a wheel wash facility so that any vehicle which is going outside from the construction site should not carry over the soil or like those kind of things outside. We should have proper material storage in the site. It should be designated also that segregation is most important for all the materials which are left over at the site. Dust suppression system should be there. Proper signage, safety signage should be available. PPEs for construction workers for the safety. So these are some of the important aspects one should take care while doing the green buildings. These are some more photographs. Now, इतनी सारी बात हो गई benefits of green building. So, first is environmental benefit, protect biodiversity in ecosystem, improve the air quality and water quality, uh, try to capture maximum rainwater as you can, and conserve natural resources. The economic benefits are when you go for a green building system, you consume less energy, you consume less water. So, lot of operating cost savings. You get lot of so in different states, a state government has given different kind of incentives. In some of the areas, we get FAR incentive. In some of the areas, we get capital exemptions. In some of the areas, we get some tax exemptions. Then again, like you improve the occupant productivity. So again, it's economic benefit. Now, the social benefits are enhance occupants' comfort and health, heightens aesthetic qualities, minimize strain or local infrastructure, and improve overall quality of life. So, a green building consume 35% less carbon emissions. We save up to 40-45% of water, 40 to 50% of energy, and up to 70% of solid waste. So this is India's one of the first certified green building, and this is also headquarter of IGBC. So this is an iconic building. So this is all from my side. So if you have any queries, we can have a discussion.
So questions and answers are most welcome from the participants. We like to thank Dr. Prateek for this wonderful and very insightful presentation. In a very short amount of time, so you have given us this presentation and very wonderfully showcased one of your projects also. So I like to start by asking regarding your project itself, that a very wonderful radiant cooling system you have shown to us. Can you explain more about it and regarding the costing also? The project which you have discussed in the slides.
So I'll just give you a background of this project. So our client just means somehow means he's a building contractor and gas contractor in US, so he understands this system. So he was just finding some people who can do this kind of project for him in India. So through somebody, he reached us that he's looking for this kind of project to execute in India. And then one of my friend Yash, he does designing of. He's a certified geothermal system designer. So me and Yash, we sat together and we worked for the design of this project. So I think this is India's first geothermal project, and means it was a lot of challenge during the execution of this project, but now it is successfully commissioned. So what happens is like this project is around 75. This is 75 kilowatt overall capacity for this project. And then we have around 20 geothermal 100-meter bores. So these boards, as I just shown, they just get connected through the geothermal machine, and then we have the other aspect of the project. So the total cost of the project to the customer, it was around 1.4 CR. And uh, so what was the other question?
Yeah, about recurring costs in such system versus HVAC systems.
Yeah. So what happens is, this is the generation side, the chilled water generation. Chilled water can be generated through conventional chillers, through heat pump, conventional air to water heat pumps. So when we do that kind of installation, so there we get a COP of 3 to 4.
Okay.
Right? And for this kind of system, so which we have translated from, for cooling we are getting around 6.8 or 7 COP, and for heating we are getting, like, in peak winters we may get 8 to 9. It means this was like we have done the testing in first week of January. So I think overall we are going to achieve around 9 COP. So in terms of energy savings, if I tell you, it is 30 to 40% more energy efficient. But in terms of cost, I think अगर जियोथर्मल वाले पार्ट को हटा के कन्वेंशनल सिस्टम लगाते तो शायद ये प्रोजेक्ट 70-75 lakhs में हो जाता.
Okay.
So we put additional 40-50 lakhs for the entire system.
Okay.
But again, like the client was really very supportive. He wanted to do this. And we identified some of the challenges to execute this system. But now we are capable of taking this system to the next level.
Yeah. So ROI will be in maybe 4 to 5 years.
See, this system we have not done for ROI. The reason is, so he lives in US. He's going to come back to India. Maybe he'll stay 1 or 2 months in India. So we calculate ROI when the system runs throughout the year.
Throughout the year, correct.
Yeah. So the second thing is, if a building which is going to run for 24 hours, like IT buildings, hotels, and those kind of buildings, the ROI will be around 4 years, 4.5 years.
Okay.
And right now, this is the estimate of ROI, because we are working on the ROI calculations right now.
Okay.
So very soon we'll come out with the entire ROI calculations also.
Because we have implemented some system in our hostels also. We are using hot water supply, and we are using the air from the same supply. We are using the boilers. So in the similar manner, this can be implemented for academic institutions also, I guess.
Yes, we are working with Club Mahindra, so we are visiting Solan, I think next week or next to next week.
Great,
so
great.
So they are planning for, they have their net zero mandate. So they are planning. So we are going to do a feasibility for them.
Okay.
So means there is a lot of opportunity.
Yeah, there's a lot of scope in this.
Yeah, especially like for heating, these kind of technologies are really very beneficial.
Correct. Especially in mountains, geothermal effect can be very easily achieved.
See,
certain depths.
See, that can be. What happens is, like, first we do a single bore.
Okay.
So first we do the feasibility of the site. Then we do single bore, and we do a TRT test. This is thermal response test. Okay. Based on the TRT test, we estimate the capacity of one bore.
Okay.
So there are a lot of parameters, soil parameters, the capacity of the bore. And then after doing the TRT test and estimating the output of the both, then we design the entire system that how we are going to balance the geothermal side of the machine.
Yeah, understood. So again, coming to the questions posted by our students, one of our student asked that as a BTech student, what tools or simulation software would you recommend that we start learning to model HVAC performance and overall building energy consumptions at an early stage?
So I think to start with, eQuest is a good option. eQuest is quite, it has good graphics. Also, you'll find lot of YouTube videos also to have a explainer. Otherwise, there are a lot of tools, but if they want to have a self-paced learning, then I think eQuest is a good option to start with.
Okay, is it a commercially available software or
No,
open source?
it's a open source software. Yeah.
Okay, so we'll maybe if you can share certain links for that, where we'll be very happy
Sure.
to give to our community.
Sure, I'll share with you personally.
Oh, thank you, Prateek. One of the questions was like how to practically compare different start-rated appliances or HVAC units when designing a building. Is there a thumb rule to it, or how do, or just we go by 5-star is the best, or is there anything else to be seen also?
So when you see, every machine has a technical small, what I say, एक पत्ती सी पीछे होती है हर equipment के.
Correct.
So let us suppose if you are going for a 1.5 ton machine, for an air conditioning machine, just have a look that how much wattage of energy it is going to consume. What is the power consumption of a machine? You might find somewhere in the technical block of the machine. Just compare that. But at the same time, actually, again, it requires a lot of skills to estimate the right technology, because again, we have some loopholes in the system.
Okay.
There is a possibility that a very good company has claimed maybe 0.5% less in their technical catalog.
Yeah.
But overall, they might be more efficient compared to a brand. So these kind of things I have seen. So again, it requires some competency at that level. But the basic thing is just have a look at the technical specifications, and you can compare from there.
One more question was that which emerging sustainable material you see as most practical for large scale adoption in India over the next decade?
Okay. See, as a person, I'm not talking about as a professional.
Yeah.
When I see the construction industry, it pains a lot to me.
Correct.
But because we are just running towards the looks of the building, the interiors of the building. See, what happens is when you go for a sustainable material. So few days back, I was just so we are doing a green building project. So I was just having a discussion with the builder. So usually when we do green building certifications, we for envelopes, we suggest that go with fly ash bricks or double AC blocks. Yes. So you get the best U values in double AC blocks for heat to not permit. And again, if so you guys are all from civil engineer background, there is a technology which is called as MyOne.
Okay.
So in MyOne technology, what happens is the entire block can be, so it is like, इसमें प्री कास्ट के अंदर आप सीधे मिक्सचर सीमेंट कंक्रीट का मिक्सचर डाल के आप पूरी बिल्डिंग एक करके खड़ी कर देते हैं.
Okay.
So the structural rigidity of MyOne technology is much better compared to normal
conventional concreting. Yeah.
Yes, but ACC blocks gives better applications if I talk about the heat loads. So the builder was telling that in conventional buildings, we may get cracks.
Hmm.
We may get the look is not that good. But in my one technology, you have very poor U values. मतलब अगर कोई छत पे एक किल्ट होके तो कई फ्लोरों पे उसकी आवाज़ सुनाई देती है. उसके बाद आपकी हीट बहुत ज़्यादा मतलब बहुत जल्दी गर्म होती है, बहुत जल्दी ठंडी होती है. So again, it's like sometimes we have to understand the requirement of the customer. At the same time, we have to think the best possible solutions, and then we have to come up with the right option. As far as the question was the technology for future, I think it's very tough to answer, but I would say one should think multiple times whilst doing the selection of the material. Sometimes technologies which don't look very good have a very good end effects. So if you want, if you're just doing the selection of materials based on looks, based on interiors, it might have different kind of consequences. So we should have a balance between all these aspects.
Actually, my intention was because we are having even our international participants from Bhutan also. So some of our alumni are working there in their sustainability ministry itself. So they were very keen to know that what kind of materials they should promote, because you must be knowing about Bhutan projects. They are building not vertically, they are building horizontally.
So what I will suggest is they can connect to me directly if they need advice on particular application. So like if I talk about, there are a lot of technologies available. So we have to select the technology for the projects itself, the climate. So like in India, we have 5 climatic conditions. If I have to design a building for Jaipur, has a different application for compared to a building in Ladakh, compared to a building in Chennai, which has a very humid climate. So climate has an effect, then budget has an effect, then the intent has an effect.
Correct.
So while doing the selection, see, I can tell them lot of materials, lot of technologies, but again, based on various aspects, we have to find the right
combination.
Yeah. So that is means one fit cannot fit in every
every shoe.
building.
Yeah.
So that is not going to happen.
Yeah. So we would like to invite if any other question is there from audience side. Otherwise, it has been such an enlightening session with Dr. Prateek. He has very meticulously and very enthusiastically shown all of our students and the participants from around the world that how sustainability is now the need of the hour. It's not just in books. It has to come on from papers to actual practical aspects. So all of our engineers today who have joined us, we are very grateful to them. We are grateful to IGBC. We are grateful to our administration and civil engineering department for giving us this opportunity to connect. I have shared a feedback link form also for all the participants to give a feedback on the same. And in hoping that in future we'll be doing more of these webinar sessions as a regular feature, and our participants will keep on joining us. So with these words, again, yes, sir.
Just one thing, Tanmay. So Prateek ji, please, you are visiting the Club Mahindra Solan. So we are just 10 kilometers from Club Mahindra Solan.
Okay.
So I am just inviting you to please visit here, and please, Tanmay, please contact with the Prateek ji.
Sure.
So it will be our honor to host you at our university. So please visit.
Sure, sir. Sure. I'll let Tanmay sir. Once my schedule is finalized, we'll coordinate and we'll plan. So I think Yash is also going to visit.
Oh, great.
So he is the designer for the geothermal system.
Yes.
So I think we'll have a visit and we'll have an interaction.
That will be great.
So
that will be great.
As Tanmay told that we are using the heat pump here basically for the airflow and also for heating the water. So we will have some interaction with you.
Sure.
So please. So thank you,
Sure.
thank you, sir.
Thank you, sir, for your invitation, warm invitation, and seizing the moment at the right time. So we hope that Prateek sir will come to us and we'll have a in-person discussion also this time.
Thank you so much for this session and for inviting me. And it was a very short duration, so me and
Yeah.
Tanmay ji, we were just discussing
Correct.
that at least we need 2-3 days for having
Yeah.
this event.
Yeah.
Yeah.
Okay. So thank you very
Okay.
much once
Thank you.
again.
Thank you
everyone.
all.
Thank you all, Prateek ji, Jagjit ji, and Nilesh ji, and after all, thanks to Tanmay for coordinating all these things. Thank you,
Okay.
sir.
All right.
Okay.